Okay. Let's see what time it is. All right. Hey guys. It is 5 o'clock, and so we're going to go ahead and begin with our test review from Unit 3, which is multiplication. So I have our math notebook here, and I just want to go over some important things, important topics that you're probably going to need to review as you prepare for the test. So the first thing is just the vocabulary. Basically, know what the difference is between each of these and know what these are and how are these two properties different from addition. So remember when we talked about addition, there were different properties of addition. There are also properties of multiplication, okay? So these things just allow us to do different tasks when we're trying to solve multiplication problems. Um, and so the first thing is multiplying by 10 and 100. So I want you to be really careful with that. A lot of times with those of you that are using partial products, I want you to be careful with the number of zeros that you are putting at the end of your products. The number of zeros, count those up first and then multiply what's left, okay? The same goes with multiplying by multiples of 10 and 100. You count the zeros and put them at the end first, then you multiply what's left. And then that will make it a little bit less confusing when you have something like 5 times 40, okay? And you kind of see that a lot in our practice. Rounding and estimating. This little word right here changes everything that you do, okay? Remember, on a test or your fourth grade expectation is that rounding makes it easier to multiply. So always round first. We round first, then we multiply. So then we're dealing with multiplying by multiples of 10 and 100 instead of using a standard algorithm and then rounding after that. It's too much work. Okay? Always round first before you multiply. Don't forget. So if you have something like 7 times 46, round it, multiply. You can round both. You can round one. When you round one, you get closer to the actual product. Okay? So review that. Next thing, we've talked about arrays, breaking up that multiplication problem to make it a little bit easier. And when you break it up, you get what's called partial products, and then you add them up to get your total product. Okay, this was our lead-in to this strategy right here, the distributive property and partial products. So breaking things up sometimes makes it easier for us to see. So for a lot of you, this is a very comfortable way to multiply because you're dealing with multiples of 10 and 100. Then you just add them up. Okay, that's partial products. This is the standard algorithm, the way that most of you know how to multiply. So we just bumped it up. We're adding more digits, taking away the heart method, and then just using the connecting lines. Okay, heart method's a little bit too messy for the number of digits that we're multiplying in fourth grade. So do not try to use the heart method. Makes it too hard to see. Okay. Hold on just a second. I just had a question. Then, right here, problem solving with multiplication. We're going to go through a lot of this today. UPS check, model drawing. Okay? Multiplying 2 digits by 2 digits. This is the partial products method, which we talked about a lot. Watch those zeros. When you're multiplying by multiples of 10 and 100, count up the zeros, then multiply what's left. Okay? And then we have the XOX method, standard algorithm. This one, just remember this shift. Okay? When you multiply by the tens, you shift over one place value, and then you put in a 0 in the empty spot. Because you're multiplying by a 10, not just 1. This part is very important right here. Okay? A lot of you watch your multiplication facts. Basic facts. 6 times 4. Okay? 3 times 8. 7 times 9. If you don't know it, then you need to make your tic-tac-toe tool to go through it and do your skip counting. Okay? Use as much room on your paper as you need to. Don't try to squeeze it all in one place if you can't. The beauty of the XOX method or the standard algorithm is that you can use very little space. You don't need a lot of room to solve this multiplication problem. But the problem with condensing it into a small space is sometimes you lose your way. You forget the steps, you don't know what to do. So if you're that kind of person that forgets what to do, or you get stuck partway through the process, or you make too many mistakes using the standard algorithm, go back to partial products. Okay? Use whatever's most successful for you. Okay? There's going to be a little bit of equations. Just as long as you know what they are and you can recognize what variables are, then you're good to go. Okay? So let's go through some of the test review. If you missed me going through the notes just now, later when the video posts, you can just watch the playback and you can, double check that you've got all those notes. Okay, everything is also uploaded onto Google Stream. What do you call it? Google Drive. So you can check that way. And I'm trying to look at kids' questions. Give me just a moment. All right, so here we have the test review, and this is also available on your email, Google Drive, Google Classroom. You can also ask your parents. You can print it if you want to, but you don't have to. You can just have it available on your tablet, and then you can use it side by side with your actual work paper. Okay? So I'm going to take you through as many problems as I can. And then if you miss one, or if I've already covered it, then as you're asking questions, I can just tell you to watch the playback. Okay? You can always fast forward. What I'll try to do is once the video posts, I'll try to leave little notes that say, if you want to look at the solution for this problem, this problem, this problem, you can fast forward to the specific timestamp. I'll try to figure out how to do that. And that way it'll make things easier for you when you're solving problems yourself at home. Okay? So here we go. Let's go ahead and get started. Let's see. Okay. So let's look at number one. A season pass at a water park costs $100. A total of 125 people paid for a season pass. What is the total cost of these season passes? Okay. So, UPS check. Okay. Do you remember what to do for all of these steps? If you need to write down UPS check as you're solving on your work paper, then go ahead. These are the things that I'm checking for when you are turning in your test. I'm not just grading your multiple choice this time, I'm also grading all of your work. So write everything down. I can't read your mind while you're taking the test, and you might not remember when I ask you later. So just write it down as you're doing it. So the U part is your sentence frame. P, your planning portion, is your model drawing. S, if you can set up an equation, great, but this is where you work out the math. Okay, and then the check process is to fill in your sentence frame. Does your answer make sense? Okay, these are the things that should be going on through your mind as you go through the UPS check process. So always start with your sentence frame. Let's look at this. The question is, what was the total cost of these season passes? So how do you answer that question in the form of a sentence? Use as many words as you can. If you're online chatting with me right now, go ahead and give me a sentence frame. And let me see what you got. Okay. Did you get one? Let's see if yours looks like mine. The total cost of the season passes is blank. So right off the bat, since we talked about building equations today, an appropriate variable for the cost of the season passes, you could choose C for cost, You could choose S for season passes or just P for passes. Any of those, as long as it makes sense to you, you can use that as a variable. Since I'm talking about the cost, I'm going to choose C as my variable. And to help me out with my check process later, I'm just going to put my variable right there so that when I find out what C equals, I can fill that back in. That is the number that's going to make sense because I'm looking for C. So let's look at the problem again. Each of the season passes costs $100. Okay, so let's do our model drawing. Each pass is $100. But we're not just buying one of them, we're buying 125. Because 125 people paid for the season pass. So we're buying that 125 times. So if we're buying this pass 125 times, my model drawing is going to look like this. And what I'm looking for is the total cost. So the total cost is what I don't know. That's C. Okay, right here. So let's build our equation. From here, we can already see what our math problem is going to be. There it is. And if you want to bump it up, add in your equal sign and your variable, and there's your equation. You already know what the math is. Bump it up to show the 4th grade expectation. There you go. So now we're multiplying something by 100. So 2 zeros. Then you multiply what's left. 1 times 125. Anything times 1 is itself. Okay. Then ooh. Okay. So I found C to be equal to $12,500. Here it is. That's C. That's what I was going to find. I can even fill it in right here. Okay. So if I buy 125 passes at $100 each, I'm going to have to pay $12,500. And there's your answer. So the checking back process is seeing what you found out. I did my math, and that gave me what C equals. Well, there's C right there, and there's C right there. So I'm checking, okay, I filled in the right numbers in the right places. So everything checks out. So if you don't fill in your sentence, or if you don't fill in everything that you just found out, maybe you didn't work enough. How do you know that you are finished? This is a one-step problem, so of course you're done. But what if it was a two-step problem? You need to make sure that you finished all of the steps. And if you didn't, then you need to keep going, okay? Push through all the way to the end. So that's the solution for number 1. Okay? Let's go on to number 2. This one, we kind of did something like this in class already, but we'll just go through it. Number 2, there are 5,280 feet in a mile. What is the total number of feet in 6 miles? So what I want you to do first is I'm going to wheel over to my desktop to see who's chatting. And then I want you to write a sentence frame that answers this question right here. Number 2, there are 5,280 feet in a mile. What is the total number of feet in 6 miles? Okay, did you get your sentence frame? If you have your notebook in front of you, you probably could flip back to that problem that we worked out in class. But let's just go ahead and work it out. Here we go. What is the total number of feet in 6 miles? Let's reword that question in the form of a sentence. The total number of feet in 6 miles is, okay, I'm looking for feet. So let's use F as our variable. So this one, I know how many feet are in 1 mile. So let's make 1 mile. There are 5,280 feet. But I'm not just running one of them. I'm running 6 of them. So let's multiply that times 6. Okay? So it's asking for the total. Here it is. We don't know that yet. We're going to call that F. You already see the multiplication problem taking place. So transfer it over here to make an equation. This is what you see in your head. This gives us a little bit more information, makes it an equation, equals your variable. Okay? So let's multiply it out. I can't multiply it looking at it like that. So I can rewrite it. It doesn't hurt to rewrite things. Let's do our work. 6 times 0, 0. 6 times 8, 48. You don't cram that 48 in there. You need to write down the 8, regroup that 4. Okay, I saw some kids trying to cram numbers in. You know better. Regroup. Okay? So 6 times 8 is 48. A lot of you missed this multiplication fact right here. So y'all need to go over your 6's. If you didn't know that fact, you've got this tool right here that you can use. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72. 6 times 8, 1, 2, 3, 4, 5, 6, 7, 8 is 48. There it is. 6 times 2 is 12. 12 plus 4 is 16. Then 6 times 5 is 30. 30 plus 1 is 31. So 31,680. 31,000, whoops, 31,680 equals F, if I'm continuing on what I had at the beginning. There's F right here. And there's F right there. This is my check back process. Okay, I found what I was looking for. I found what I didn't know. And when I went back through, everything was complete. And it makes sense. Okay. So let's read number 3. Nathan washes 26 cars each day. He works at a car wash. He worked 34 days during the summer. About how many cars did Nathan wash during these 34 days? Okay. So let's come up with a sentence frame. Read the question very carefully. And when you're building your sentence frame, make sure to use the words that are in the question. Reword the question as a sentence. Read carefully. Did you catch it? Did you catch the word of why I wanted you to read carefully? It says about how many cars did Nathan wash? About. So, what should we do? What does that mean? When you see the word about, what does that mean you should do? Are we doing XOX method? I hope you did not say yes. When you see that word about, that should be a huge hint that we've got an estimation problem. Okay? This is number 3. So with estimation, we want to round the numbers in a way that makes it easy for us to multiply. Okay? I don't want to do too much work, not for this one. So what was your sentence frame? Nathan washed about blank cars. Okay? If you use those words, especially this one right here, it's going to remind you, okay, about means estimate. About means estimate. Estimate means round. Okay, I need to round the numbers. So, if we've got 26 cars, he washes 26 cars in each day. Well, 26. About how much is 26? What does 26 round to? Let's make that a nice round number that would make it easy for us to multiply. 26 rounds to, let's see here, if you need to know. The 6 tells us that this digit does what? It goes up. So this is about 30. He washes about 30 cars every day. Okay? And then, how many days did he work? Well, he worked about 34 days. Okay? 34 days. About 34 days. About how many days is 34 days? Let's round that one too. I don't want to work too hard on this problem. Whoops. The 4 tells the 3 to do what? Stay the same. Okay? So,
Miss Boucher, if you're still in the building, can you call Miss Allen, Miss Boucher?
sorry, I'm still at school. We're going to get interrupted. So, we've got about 30 cars every day for about 30 days. Look at that. I have 2 multiples of 10. So, we can do 30 times 30. And what is that going to give us? It's going to give us the total amount of cars. And what can we call that? C? Okay. How many zeros are there? Multiply what's left. 3 times 3 is 9. Okay, that's about 900. And this is about 900 cars. So, with an estimation problem, I want you to remember that you're estimating to make your life easier as far as multiplying goes. So when you round both, it definitely makes it easier because then both are factors of 10 or 100. Okay? You're going to get an answer that's a little bit farther away from the actual answer, usually. We found that when we rounded 1, then we were able to get closer to the actual answer. So be careful with that. Read the problem very carefully. If you round both and this doesn't match any of your answer choices, this is how I got to the answer when I rounded both. But if this is not any of my answer choices, what can I do? It's my other strategy. If rounding both doesn't get me to what I want, I can also do this. And you just round one of them. Okay, well, let's look. This is round both. What about rounding one of them? Let's see here. Let's keep this him washing about 30 cars a day. But let's keep this at the exact number. He does it for 34 days. Well, you're still looking for the total. There's 1 0 here. But I need to do 34 times 3. Eesh, I'm going to put that to the side. 9, 10. So when I round 1 instead of both, then I get a different answer. But maybe this is one of your answer choices. The problem with estimation is you don't really know exactly what you're going to get because you're not looking for an exact answer. So if you use one rounding strategy and it doesn't get you one of the answer choices, try another strategy, okay? And then you could switch, keep that number and round the other one. But when you round one, you're dealing with having to write out the multiplication anyway. I don't like to do that in general, just because if I'm going to round, I don't want to have to do this work, okay? The whole point of rounding is to make your life easy, okay? Not to keep it hard. So for me, rounding both would be the most sensible choice, okay? If this was a single digit, okay, maybe I could see not needing to round that one, like this example right here. I don't need to round this 7, even though I can, because I already know when I round this number, I'm multiplying by a multiple of 10, okay? But when you're dealing with 2 digits, just be careful with your strategy. All I'm saying is, you know there's more than one way to get to an answer, especially with rounding and estimation, okay? So try a couple of different things. Don't get stuck. If you do get stuck, try to think of another way you can arrive at the answer without actually multiplying out those two numbers, okay? Estimation means round first. Okay, there you go. All right, so let's move on to number 4. Okay. Jim baked sugar cookies and peanut butter cookies. He baked 8 sugar cookies and 3 times as many peanut butter cookies. What is the total number of cookies that Jim baked? There's the question right there. Let's see if you can come up with a sentence frame. Okay, so what is the total number of cookies that Jim baked? Jim baked blank cookies. Okay? Just reusing those words. So, he didn't just bake one kind, he baked two kinds. He's got sugar cookies and peanut butter cookies. Do we know how many sugar cookies he baked? Yeah, he got 8 of them. So, let's assign that variable. Let's do C right here for cookies. Okay? You know that he made how many? 8. And the next kind that he baked were peanut butter cookies. Do we know how many peanut butter cookies he baked? It's not an exact number, but it says 3 times as many. 3 times as many. So I can take this and show it 3 times. 2, 3. It's also a multiplication problem. Okay? This one is 8. And this one is, what's 8 times 3? I hope you know. 24. So, sugar cookies is 8. Peanut butter cookies is 24. Okay? If I want to, I can bring this to the other side. Okay? So, those are the amount of cookies, but what am I trying to find? C. Well, how do I find C? What is the total number of cookies that Jim baked? So what should I do now? I know how many sugar cookies I've got. I know how many peanut butter cookies I've got. But what am I going to do to find C? I only have S and PB right here. I think you know. We need to add these numbers to find the total. Okay? So, when you add them together, the total is C. Okay? So, let's do S plus PB is C. When you add the sugar cookie and the peanut butter cookies, you get the total number of cookies. So this is 8. Peanut butter is how much? 24. We don't know C yet, but let's add 8 and 24. How much is it? Do you know? Can you beat me? I'm ready. 32. C is 32. C, 32. If you had stopped here at finding out how many peanut butter cookies there are, there probably is going to be an answer choice that has 24. Trying to catch the kids that want to finish early. But if you use variables, this is the importance of variables right here. You know that's not C. That's not C. Well, how do you find C? You have to think about it and continue working. Okay? This requires a lot of thought. This is a 2-step problem right here. You've got to multiply first, then add them all up. Okay? So don't get caught on a problem like this. It feels easy. The facts are easy. But it requires a lot more thinking to get to the final answer. So take your time on problems like this. Okay? Don't get caught. So let's look at number 5. What is the product of 13 and 15? This was just kind of a vocabulary question that I threw in there. You know what that means? What does this word mean you have to do? Am I going to add? Am I going to subtract? Am I going to multiply? Or am I going to divide? What does product mean? Hope you know. By now, I hope you really know. But if you ever see this vocabulary word, it means you're going to need to multiply. Okay? So here we go. 13 times 15. I'm going to do XOX because that's actually my preferred method. But again, you use whatever method is best for you to not make any mistakes. Okay? You should prefer the method that gets you 100 rather than saving space. Making 100 is more important. Getting it all right is more important than saving space. Take up as much room as you need. But I'm going to do XOX. 5 times 3, 15. Regroup that 1. 5 times 1 is 5. 5 plus 1 is 6. Okay, X, O, X. 1 times 3 is 3. 1 times 1 is 1. Add this partial products. The product is 195. Okay? You may be screaming at this point, Miss Vo, what about UPS check? When it's not really a story, I'm not going to worry too much about UPS check. When you're not given a story about things happening, don't worry about UPS check, okay? This was more of a vocabulary question. And then it wanted to see what you could set up. Did you know that you needed to multiply? Okay? So, yes, you could have maybe stretched a little bit and tried to make this a UPS check problem, which is fine and I'll accept it. But if you did not do UPS check on this problem, that's okay too. As long as you knew you needed to multiply. But Miss Vo, how do I know when to do it and when not to do it? Well, do you see anybody's names listed in here? Do you see any real life scenarios going on in here? No? When you don't see names, you don't see real life scenarios, you don't see any words that don't deal with math at all, it's probably not a UPS check problem. Okay? So, you're off the hook with this one. Here we go. Let's look at number 6. The list below shows the number of picture frames Shelley sold on each day of an art sale. Okay? Multiple days. She sold 16 picture frames on Thursday, 22 picture frames on Friday, and 25 picture frames on Saturday. Thursday, Friday, Saturday. The cost of each picture frame was $14. What was the total cost of these frames in dollars? All right, so there's the question right there. What was the total cost of the frames? The total cost of the frames is blank dollars. Okay. So let's look at this problem. What are we dealing with here? We're trying to find the cost. Okay, we want the total cost. Maybe T would be an appropriate variable, T for total, or C for cost. Either one would work. This time I'm just going to choose T for total, okay? It's going to help me out. T for total. That makes sense? Okay. Okay. So let's look here. She had a 3-day sale. She sold things on Thursday. She sold things on Friday. She sold things on Saturday. Okay. How many did she sell? 16 of them. We're trying to find out how much money did she make. So how much was each frame? There it is, $14. So she sold each frame for $14. She sold frames on Thursday. How many? 16. How about Friday? Also 14. But how many picture frames? 22. How about Saturday? 25. Okay. So how much did she sell on Thursday? How much did she make on Thursday? How much did she make on Friday? How much did she make on Saturday? You could do it this way. There's another way to do it. If you're trying to find the total cost and you know how many she sold on each day, let's think about it in a different way. You know how many she sold on Thursday. You know how many she sold on Friday. You know how many she sold on Saturday. This is a different way to look at it. She sold 16. She sold 22. She sold 25. What's the total number of frames that she sold? Okay, let's see here. 8 plus 5 is 13. 4 plus 1 is 5, plus 1 is 6. She sold a total of 63 frames over the 3 days. 63 frames. But can I put this in here? No, I'm looking for a dollar amount. That's not the same thing. Why would I choose to do it this way rather than this way? Both ways are correct. You could do 3 separate multiplication problems. 14 times 16. You could do 14 times 22. You could do 14 times 25. XOX method 3 times. And then add to find the total. Who wants to do XOX method 3 times? Oh, maybe you do. Some of you really like it. But there's a lot of room for error here. All your multiplication facts, everything like that. For your part, you are better at addition. So why not just add them up first? She sold a total of 63 frames. Well, each frame, no matter what day it was $14 a piece. So now you have one multiplication problem, 63 times $14. So let's multiply that. 4 times 3, 4 times 6, 24 plus 1 is 25. X, O, X. 1 times 3 is 3. 1 times 6, 6. Add these up. 2, 8, 8. $882. That's my total cost. Okay? And there it is. 882. Do you need an equation? 63 frames times $14 a piece is going to give me my total cost. There's my multiplication. There it is. You could work all of these out and add them together and find the same answer. You could just stick with this way. So it depends on how you see it. This is totally an okay way to do it. Okay? This is also a totally okay way to do it. So, just know there's multiple ways to get to the solution. One of them is definitely less work than the other. but you choose. Okay? For me, adding first before I multiply makes the work a little bit easier. Okay? It would have been a mess trying to do all 3 multiplication problems and then trying to add it up at the very end. Okay, let's go through number 7. I think somebody was asking about number 7. Here we go. 2 adults and 13 children are going on a camping trip. They need to buy 1 sleeping bag for each person. Each sleeping bag costs $30. What is the total cost of the sleeping bags? Okay, so we've got 2 adults, 13 children. Everybody gets a sleeping bag. There's the cost of each bag. What is the total cost of the sleeping bags? Let's answer the question. Real life scenario, UPS check. This time, I'm going to go ahead and keep it at T for total. Okay, so we're trying to buy a sleeping bag for all of the people. Well, how many people are there? Some of you may say, Ms. Fro, there's 13. If you choose the number of people to be 13, what are the adults going to sleep in? You're going to make them sleep out in the open? The cold, hard ground? Gets cold at night, especially right now. They're going to want sleeping bags too. So how many people do you have? Okay. People are going to be adults and kids. How many adults did you have? 2. How many kids did you have? 13. So the number of people that you have is 15. You've got 15 people that you need to buy sleeping bags for. Okay? So each sleeping bag costs how much? $30. How many people are you buying it for? 15. There's your model drawing. And you're trying to find the total cost. Okay? That's what you don't know. There's your multiplication problem. 30 times 15 equals T, or total. Ooh. Let's do this. Okay. 0, 0, X, O. There's nothing to X up there. 3 times 5, 15. 3 times 1 is 3, plus 1, 4. 450 is my product. 450 is equal to T. Okay, bringing it back to my sentence form. Okay, there's T right there. That's my total. And there's T right there. It's going to be $450. Okay? All right. Here's number 8. It's the same as number 1. Yay. So we don't have to do that one. Let's skip ahead to number 9. Carver Elementary is going to sell hamburgers at their fall carnival. They purchased 407 packages of hamburger buns. Hamburger buns come in packages of 10. How many hamburgers can they sell at the carnival? Build me a sentence frame. they can sell blank hamburgers at the carnival. Okay, so we're looking for the number of hamburgers. Let's use H. That's my variable. Okay, they purchased 407 packages, but each package has 10. So here's a package with 10 buns. Well, how many did they buy? 407 of them. And then you're trying to figure out, well, okay, if you've got 407, if you've got 10 hamburger buns, that's a set, the top and the bottom. That counts as one hamburger bun. Okay? If you've got a set of 10, how many hamburgers can you sell? You can sell 10. Okay? 10 buns, 10 burgers. So, what if you had 407 packages? Let's find out the total. Total number of hamburgers, which is H. Okay? So, let's set it up. 10 times 407 equals H. You already saw the math problem. There's the equation. Okay? Oh, look, I'm just multiplying times 10. There's a 0. Just this one. That one doesn't count, remember. It's not at the end of the number. 407 is not a multiple of 10. Okay? So I've got 1. Take 407, multiply it times 1. It's 407. H. There's H right there. That's the total number of hamburgers they can sell. Okay? Does that make sense? Alrighty. Let's go over, skip ahead to number 10. Oh, trucking along here. Number 10. Miss Vo can run 32 miles in a week. Well, not anymore. It's my foot. But you know. If she rides the same number of miles each week, oh, sorry. How many miles will she run in 37 weeks? Sorry, this means run. If she runs the same number of miles each week, about how many miles will she run in 37 weeks? Did you catch it? I hope you did. There's that word right there. What does that mean? It means we have an estimation problem. Oops. Hold on a minute. Sorry, my screen just turned off. But I think the live stream is still okay. Small technical difficulty. So about means we're going to need to estimate. Alrighty. I run 32 miles every week. 32 is about how much? It's about 30. Okay. 37 is about how much? I'm not about to do any standard algorithm math here. It's an estimation problem. 37 rounds to what? 40. Okay, so we're going to multiply 30 times 40. And what does that give me? The total, which is miles. Let's do M. Oh, I forgot my sentence frame. Miss Bo, I bet you're screaming at me. Sorry, the screen turning off kind of messed me up. So, did you write a sentence frame already? Miss Bo ran about blank miles. Okay, that's M. 30 times 40 gives me M. All right, 1, 2 zeros. Multiply what's left. 3 times 4 is 12. Okay, 1,200 miles. There's M. Fill them all in. Check back. All right, we're back in business. Okay? Really pay attention to the words in the question. You see that word about. You know you're not looking for an exact answer. Luckily, you have answer choices on your side. You see rounded answer choices. That's another clue that you probably should have rounded. Okay? So, I round both to make the multiplication very easy. Don't try to make your life hard. It's hard enough as it is. Okay, let's do number 11. The IMAX can seat 1,436 people. On opening weekend for the new X-Men movie, they sold all of the tickets for 5 shows. How many total tickets did the IMAX sell for the 5 shows? Okay. How many total tickets did the IMAX sell for the 5 shows? Total number of tickets sold is, okay, get your sentence frame in there. The whole theater can hold 1,436 people. Okay, you've got one theater showing that movie, X-Men. And if they fill it up, and every seat is filled with a person, how many tickets did they sell? 1,436. Okay, per show. So this is one show. How many shows did they sell out? 5. And you're going to try to find the total number of tickets that they sold. What's my variable? Total? There we go. T. The math's already from the model drawing. It's looking at you in the face. There's the math. There's the equation. Okay? Let's multiply. 5 times 6, 30. 5 times 3 is 15, plus 3 is 18. 5 times 4 is 20, plus 1, 21. 5 times 1 is 5, plus 2 is 7. 7,180. There it is. Okay? Multiplication, equation, model drawing. Let's go on to number 12. All right. Number 12. Manicurists at a nail salon charge $32 for each spa package. If they sold 46 spa packages, how much money did they collect? Not including tips. How much money did they make? $32 per package, but they sold 46 of them. Where's your sentence frame? Oops. Sorry. How much money did they collect? They collected what can we use as the variable? Money? M? Okay. So each package is how much? If I buy one package, it's $32. That's one. Well, how many of them did they sell? 46 times 46. And that's going to give me my total amount of money, which is M. Okay, there's your equation. Somebody online requested to show it using partial products. So I'll do XOX first, and then I'll show partial products over here. Okay, 2 times 6 is 12. 3 times 6 is 18, plus 1 is 19. X, O, X. 4 times 2 is 8. 4 times 3 is 12. Line up those place values. Add 4, 1. Okay, M is a dollar amount. Let's check it. If I expand 32, it's 30 plus 2. If I expand 46, it's 40 plus 6. 40 times 30, that is 2 zeros and 12. 40 times 2, there's 1 0, 8. 30 times 6, there's 1 0 there, 18. 2 times 6 is 12. I'm going to add them all up. 1,200, 180, 80, and 12. Add 2, 16, 17, 2, 3, 4, and 1. My answer is exactly the same as the one before. Okay, there's partial products. Okay, let's move to number 13. We're almost there. 13. Mrs. Anderson is decorating for a special event. She bought 74 packages of balloons. Each package had 22 balloons. About how many balloons does she have to use for her special event? There it is again. Did you see it? There's that word. Okay, you have to read carefully to catch it. About how many balloons did she have to use for her special event? Mrs. Anderson used about blank balloons. Okay, so that's the word that we need to focus on. Each package had about how many balloons inside? 22 is about how much? It's about 20. There's about 20 of them in there. But she bought 74 packages. Well, about how many is 74 packages? The 4 tells the 7 to stay the same. Okay? And we're going to find the total number of balloons. Let's use B for balloons. One, 2 zeros. 2 times 7, 14. There's B. Let's fill it in because that's B right there. Mrs. Anderson used about 1,400 balloons. Okay? All right, 14. The Williams family went to the state fair last weekend. They spent a total of $132 for the evening. The 4 family members paid $21 each to play games at the Midway, and they spent the rest on food. Write an equation that represents F, the amount of money spent on food. So there you go. Here is an equation-specific question. It even gives you the variable that you need to use to represent the amount of money spent on food. Okay? So, let's think about what's going on here. Write an equation that represents F, the amount of money spent on food. Do we know how much money they spent on food? No. A variable is what you don't know. So if you want to think about it, what is food? Food, food. How much money did they spend on food? If you think about it like that, you're asking yourself the question that a problem probably would ask if it wanted you to actually find the answer. So, F is the amount of money spent on food. Do we know it? We don't know it. How much did they spend on food? I don't know. We have to figure that out. Okay? So, let's see here. Let's start from the beginning. 4 family members. There's 4 of them. Okay? This is where we sift through the problem and find pieces of information that we need. There's 4 people, but each of them spent $21 to play games. Okay? So let's look at the games here. They did some games. And what else did they do? They bought food. Did they do anything else at the fair? They played games. They bought food. Did they ride any rides? No. They read any books? No. Did they spend their money on anything else? No. So, what can I use for games? G for games. F for food. How much did they spend on games? We already know that. $21. But just $21? Read it carefully. Each person in the family spent $21. How many family members are there? There's 4. So, for the games, that makes sense to me. Also, that makes sense to me. Okay? So, you could add 21 4 times to find the total amount spent on games, or you could just multiply. It's a little bit easier. But I still don't know how much is spent on food. There is something else that I know. I know the total amount they spent the entire time they were at the state fair. The total of games and food is $132. Okay? So, I still don't know this. Well, how can I find this? Well, if I know what this is, I can take this piece away from that. And then that leaves me the piece that's left. Okay? So, I can take the total, which is 132, subtract whatever this is. Okay? If I want to multiply it out, that's fine too. And what does that give me? This is the math that I have to do. But where's my equation? Write an equation that represents this. Where does that go? You're missing two pieces now. You've got the math. You need the equal sign. You need the variable. This is why I went through the trouble of building equations in all of the other problems, okay? So that we can get into the habit of using a variable and building it up. Because when you get to a problem where it asks you to build an equation, it gives you 4 answer choices, then you need to be able to recognize which one is right. This is how much in the games. How much are the games? 21 times 4. You can do the math if you want to. It's 4, that's 8. You could also have looked for an answer choice that was something like that. That is the same as that. Okay? So, the intention of a problem like this is for you to understand what all the numbers mean in a problem. Don't just start randomly pulling numbers out and trying to add, subtract, multiply, or divide. You have to really understand what's going on in order to build an equation. And so this is what's expected of you in 4th grade, is being able to analyze a problem. Okay? Here's an example of when it doesn't care about the final answer. That's why I try to tell you today, we're not looking for final answers. I want to see your setup. Okay? And I'll be looking for it. Last one. Hooray! Okay, so this was number 14. Sorry. 15. A panda can eat 134 pounds of bamboo twice a day. How many pounds of bamboo can the panda eat in 7 days? Okay, did you build a sentence frame? If a panda can eat 134 pounds of bamboo twice a day, how many can the panda eat in 7 days? Pounds, let's use P. Or are you going to get confused with panda? If you think you're going to get confused, use B for bamboo. Okay? Remember, as long as you can remember what your variable stands for, then use it. Okay? It's helping you with your problem solving process. So, there's my sentence frame. A panda can eat 134 pounds in a day. We're looking for 7 days. 134 pounds in one day. But we're looking for 7 days. What is the total amount of pounds? 134 times 7 total. It's going to give us B. There's my equation. Four times 7, 28. 7 times 3 is 21, 22, 23. 7 times 1 is 7, 8, 9. 938. 938 equals B. The panda can eat 938 pounds of bamboo in 7 days. And we ended with a light one. So, a couple of things I want you to remember for the test. Okay, first one is remember UPS check and model drawing. Okay, you don't have to set up equations for each one, but it is good practice now that you know how to do it. Try using it, because what if you get to the problem that asks you just for the equation? Make sure you know how to do it. Okay, UPS check, model draw. Check your multiplication facts. If you don't know them, use your skip counter. If you get stuck skip counting, use your counter dots. Okay? This tool is really going to help you with your XOX, partial products, all of that. A lot of you miss 6 times 8 on your homework and your practice activities. Write it down. Take the time to do it. Okay? Show all of your work. Remember, you're getting 2 grades for this one. You've got your multiple choice grade and your work grade. So I'm looking for all of your work. Be neat. Okay. Be organized. Make sure I can read it all. Okay. I see a lot of you using lines to separate things like that. That's fine. Helps me see it. Labeling numbers that you're working on, that helps too. Okay, be neat, be organized. If you get stuck, move on, but try to come back. Okay? Manage your time. The test is 10 questions. You have 1 hour. So pace yourself. Don't spend 40 minutes on one problem. You get stuck and frustrated, move on and come back to it later. It's 10 questions. It's enough time to show all of your work. Okay? double check all of your strategy. Pick the one that's going to give you the least amount of mistakes. All right, with that, I'm going to go ahead and sign off. I've been online for a long time, but we worked through all the problems. Go ahead and re-watch the playback as many times as you want to. Once it posts, I'm going to give you timestamps to fast forward to get to specific problems. So that's my way of helping you out. But go ahead and re-watch this video as many times as you need to as you're working things out. Maybe you've already signed off. That's okay. I know it's a long one. Okay. So good luck preparing for the test. You will do well as long as you prepare. Okay. Just keep practicing. And we'll go over some more problems in class. All right. Good night, guys.